So I'm Tim Trahan. I work in Tokyo with Mujin, this company. And today I want to talk a little bit about what we do and also, well, actually, here's the list of things I want to cover today. So I'm going to cover about what we do, what's Mujin, also our opportunities, and also I have some time for Q&A as well. And some of the talk that I have as well in this is quite technical about some of the things that we've achieved with robotics over our time. But again, feel free to ask questions anytime. So just about us, we're a company that's really about making industrial robots for everyone is our goal. We're all about doing this, and we're doing industrial robotics. Right now, the state of the industry is that these robot arms, they're decades old tech. It's already been developed quite extensively. It's quite state-of-the-art machines these days, but they're not used very widely. And so Mujin was founded as a way to make it easier to use these robot applications. And this is kind of the type of application that we're doing. This is actually just this is a prototype that we did that was based on using the kind of software, the technology we developed. You see how right here, this robot is having a hard time with moving this petri dish with water in it. But we were able to make a system here. This is the way that we develop software. We develop software that can make it move like this instead. It's drastically different because what our software does is it automatically determines a motion path based on constraints. So yeah, that's one of the this is just a demo. We never really sold it or anything like this. But yeah, we're really about developing automation. And this is kind of how we actually had it during one of the expos that we did in Japan back in 2012 at the time. Actually, I think it was 2013. But it just shows about kind of what Mujin is really trying to do with our automation. We've done other kinds of robots as well too. I want to move on to the next slide. But first, before I go into that, I want to a little bit of background about our company. So again, we're founded in Japan, but we're founded by actually American and also a Japanese person in Japan. And the reason why we decided to set the company in Japan is specifically because Japan's really strong with these industrial robotics systems. And the types of applications that we're doing are involving using the robot manipulators. And most of them are, especially when we founded the company back in 2011, about 70% of those manipulators were made in Japan at the time, across the world, right? And just about Mujin, our company, the name Mujin, it has a double meaning. One means no people, and it can also mean no limits as well too. So yeah, that's a little bit about our founders. And we want to be able to automate pretty much any kind of system that can be automated. And this is one video that I want to show you about a type of system that we made for a company called Fast Retailing. They have the brand called Uniqlo, which I'm not sure if you have one of those in Pennsylvania or in Philadelphia, but no, you don't have one?
Oh, yeah.
Oh, you
Uniqlo
do?
store? Yeah.
Okay.
Clothing store. Yeah. I've been
exactly.
there. You've been there, right?
So,
yeah. I have a vest from there.
Awesome. So it's kind of a big deal in Japan. That's sort of like most Japanese people shop there, right? And they're having this job of people having to pick up items in boxes or e-commerce. Like you order online, you have to have somebody to pack that order for you. And so they wanted a robot that could do that kind of job automatically. And so we helped them make it using these sensors, also the software that controls the motion planning as well too. We've actually been making these kinds of systems now for quite a bit, but that's one example of some of the applications that we're doing. Other ones as well too. We developed, yes, go ahead.
When you talked about the application to Uniqlo, like for binning the products that people order.
Yes.
Does the automation only take care of like if you place the bins next to the robot and give instructions to the robot on what items and which order to make, you solve all the scheduling problem and everything, and then does it do the task, or does it go to the bins are placed in one place and it goes to the bin, picks the right object, comes back?
So yeah, the issue about bringing the actual items to the robot That's one thing that we've actually, there's a lot of different systems that we usually have to interface with, and it depends on the system as well too. But there's usually a warehouse management system that tracks what is in what bin, for example, right? And then there's going to be these automated conveyors or sometimes AGVs. They're going to bring the items to the robot.
Okay.
And so what Mujin we can do with our platform is it can figure out how to pick up the items and pack them properly. And then it can also control all of the automated systems, the industrial automation systems on the scene, including the AGVs and the conveyors as well too. Barcode scanners, all these different sensors as well too that are involved. So actually, let me show you this next video as well too. Did you see our video about JD.com? So it's a big e-commerce giant in China. And we helped them make a fully automated warehouse back in 2017 when we started that project. Finished up in 2018. But this is what it is. It's a massive warehouse. See the video here? And they were already planning on building it out to have the latest kind of automation tech for storing all the items, the automated shelving, the automated packing systems, these kinds of things. What we provided for them was the robot arm that could pick up all the items, put them into the shelving system, take them out of the shelving system, scan them, and then put them into different workflows after that. So we kind of closed the loop around the automation for this. And right now, so usually this kind of, like they were thinking they would need to have about 50 people to actually do that packing task. But by adding our robots, they're able to make it so that nobody actually has to touch any of their merchandise anymore. So the only people working at this warehouse are 5 people who are doing maintenance on the machines. That's it. So it's the most automated system I've heard of. Yeah, go ahead.
Oh yeah, this seems like a very different kind of system than what I have seen on videos about like Amazon warehouses, where you have like these small robots picking up like racks, and then people have to like pick things out and like package them.
Yeah.
So what do you think are the pros and cons? I guess in my mind, these are 2 approaches to this warehouse automation problem. So what do you think are the pros and cons of like Mujin's?
So like, what's the difference between building this kind of system and building Amazon's system of moving the items and then having a person pick them out of the shelving, things like this? So I think that maybe there's some distinctions is that, for Mujin's system, sorry, Amazon system, I understand they have a very different idea about how that they should actually handle the items in terms of where to store them, because they don't know where they're going to be shipped from and things like this, and what's the closest destination. And this is information I've gathered from Amazon's video as well too. Is I think I watched like a 20-minute video about what their automation center was doing. Our main goal is to make the system as autonomous as possible, and so we can find out a way that we can make it so that nobody actually has to handle any of these things. It's all done by machines. That's what we wanted to do. And actually, we didn't have that big of a part in deciding about how this warehouse was made. What we were in charge of just was like providing the robot application that would make it so they could take those last 50 people out of the process is all. So I think that if you think about like Amazon's system that we have right there, like right now it brings it to a person, like the system will bring the rack to the person will pick and then pack, right? If we could have Mujin in there, then it could do the picking and packing as well too. Yeah, but the automated storage system, that's something that's really different from what Amazon came up with, right? Yeah. I don't know that much about the pros and cons. It's a little bit, we focus on this kind of the robotic side of things more than the warehouse management side of things. Yeah. Any more questions about that one? Okay. Well, let me go on to the next part too, and just about Mujin, what are our products? I want to go over that a little bit too. So, and the reason why I go through this kind of thing is because I know that maybe you know a lot more about robotics than the average person does. But I do this kind of presentation for lots of different audiences, and they want to understand about what is it that Mujin actually makes. And what we actually make is a controller that we're able to connect to any kind of hardware, and also automate as I mentioned, the systems that are on the site as well. And essentially, it can be the brains of the robot, so that it can decide by itself how to do it, and it uses sensors as well too. And the key thing about how we automate the robot manipulator is that we use this technology called teachless. which if you're in the industrial automation industry, what you understand about what people are actually doing to make these robots work is that they'll program the robot to move from point A to point B, grasp something, put it down over here, or move the robot over here, make a weld, these kinds of things, right? And maybe you've also seen for like using cobots, you can sometimes do that just by pressing record, moving the robot, and then press stop, and then press play, and it'll just keep on doing it again and again. Well, so what this system is able to do is able to provide better performance than these traditional methods of robotic programming because of the algorithms that we're using. And so that's the reason why they're faster. We call that kind of technology that we built is motion planning. Yeah.
So when you talked about these algorithms that you
Yeah.
use, is there like reinforcement learning or some kind of learning involved in the design, or is it more of a theoretical control heavy approach to it?
That's a good question. Yeah. So our system is actually a model-based control system.
Okay.
So of course we're simulating everything, and there's some reasons why we actually don't use so much of the machine learning in our system right now, and I can tell you more about it later on as well too. But maybe whenever I talk more, you'll kind of understand a little bit about the challenges that we have to solve and why we chose not to use machine learning for the majority of things. Having said that, though, we do use a little bit of it, but not that much. Yeah. These slides that I have here are actually just like examples of more applications. But the reason why I want to show them to you is because you can understand about the practical benefit of what our customers are getting from using the systems, right? Because Mujin, we're really a company that's really excited to work in the real world and make robotics that are actually going to be used by people. So this JD.com example is one. I explained a little bit about the benefits that provided as well. And then I want to show you also one of these applications that's really selling very well right now, which is around actually palletizing and depalletizing. If you know what in a warehouse, you know what a pallet is, and you put boxes on the pallet or take them off. That's what these applications are. And we've actually gotten really famous in Japan for these kinds of applications in industrial warehousing. So this video right here shows this company is a warehousing services provider. They service these major grocery stores in Japan, and so a person can usually do about 400 of these boxes an hour is their performance, working really hard, and it's backbreaking work, and sometimes it's not heated or not air conditioned, and so this company in particular was having a hard time in keeping people on the job of doing this kind of thing. And so they asked us to help out with the robots because it's a no-brainer for them. They need the job to be done. There's nobody to do it. Our system does about 600, 650 boxes per hour now. So it's really replacing people. It works 24/7. And another important thing too is that as people take breaks, they take lunch breaks and things like that, there's a flow of these items around the warehouse. And the flow is much more stable. There's no need for any buffer space and things like that. So it actually increased the productivity of the system, the entire warehouse, quite a lot. Another typical application is around factory automation. And this is one that we solved quite a while ago. Well, this is a manufacturer, they make valves. And what our robot does, is, let me show you the video here, you can see it easily. There's a box of these pieces. And what the robot does is it picks them out, they're just scattered inside the box, picks them out, puts them into a jig, and then that part goes on to further in the manufacturing process. But the nice thing is that people don't have to do this job anymore. It's an incredibly boring job. It's just picking up parts and putting them in some other place. And they were able to reduce the cost of making the parts by 25% by using this kind of robot. Yeah. So this video right here shows what we're doing. It also shows that you'll see right here some of the computer vision that's used as well too. It's scanning the items. And then there's a part, there's this screen right here shows what we're getting for the detection of each object's pose as well. And then there's also in a few minutes, let's see if I can fast forward. The interface for the system here, which is also showing an animation of the machine state. So I mentioned model-based. Yeah, go ahead.
A quick question. Do you make hardware itself or do you mainly work on the controller software?
We mainly work on the controller software. Yeah.
And so that's why you use yes power here.
Yes, and Fanix in the other one, and yeah, exactly. We're compatible with most major manufacturers. Yeah. Anything else? Okay. So the reason why we decided to make this company and the focus on this kind of software for robots is to solve these big problems around using robot arms and making them easy to use in real industry. Is what really happens is that each of these manufacturers, they have different programming languages you have to use to be able to make them work. So, you know, it's different skills that are needed to set them up, of course, which makes it hard to use them. Then also it takes, as I mentioned, it takes a long time to teach these robots how to actually do it. It takes a specialist to be able to do it. Adding sensors to this to make them more autonomous is even harder of a task. And it's difficult for even robotics experts. And all these things have the same thing in common, which is the controller itself. And so we set out to make a controller that would be able to be teachless and also integrate the latest technology and sensors as well too, to do these kinds of applications to make them real. And so what our system does is it's compatible with multiple robot arms, it's teachless, and it also includes machine intelligence, which is being able to use the data from the sensors to make smart decisions about the next steps. Yeah, so back to this slide as well here, which is just showing about what we do. Again, making the unified teachless robotic controller. This is the first kind of product in the world, actually. And it's doing these kinds of applications around pick and place that before we invented this kind of system, no other company was able to make this really commercially viable.
If you have arms with different degrees of freedom, the same controller can be applied to.
Yes, absolutely. Yeah, so we have in our lab in Tokyo, so we have a big variety of robot arms that are being used, probably about 50 different robot arms from different makers. Yeah, including cobots as well too, big variety of different things. So just to recap again about one of our products as well, there's three main kinds of applications that we're really specialized in making right now, which is the factory automation ones, the ones around logistics, and then also we do provide the software as an OEM for other manufacturers as well. And we've actually sold already about 600 of these systems, actually more than that, to clients around the world, and quite a lot of them in the United States, the majority of them in Japan and China, of course. So I want to go into a little bit about what happens in our robotics lab back in Tokyo. So again, like going into our technology, I want to introduce a little bit about some of the challenges that we overcame with this. And I want to go into three different things that you have to think about. It's basically organized into like the teachless system. What is that? And then also, what's the software that's involved in making this kind of system as well? And then what's the kind of practical challenges that we faced that I think a lot of people maybe don't think about whenever they're thinking about making this kind of application as well. So just about teachless. So the first thing is I want to introduce what is motion planning. So what we're thinking about whenever we're making the robot move automatically is how to avoid the obstacles. Of course, there's the mechanical motion of the robot itself, the characteristics of the device, as you had asked earlier as well, like how many degrees of freedom does it have, these kinds of things. The stability of the grip is a big thing as well too, of actually getting the workpiece across. Error recovery and verification, and then also, it has to be goal oriented as well too. And you can see here an example of the system right here. It's picking up things and it's putting them down very carefully. This is actually a sorting system that we made before. And it takes a lot of different kind of systems to be able to make the robot actually perform these kinds of tasks. And you notice one of the things that it's doing is it's actually putting down the items relatively carefully. It's not just dumping them or something like this. Because in practical use, what we found is that clients, that if you damage the software, or not the software, the pieces you're handling and things like this, then it comes back to them as damaged goods. And so these robots have to be really capable of handling things carefully. So what this is this is the killer application we came up with the software, which is around picking things up, right? And what we solved was based on the object position. We can automatically generate and execute the movements. And of course, the path has to be executable. It has to keep on moving without stopping. And actually, some of our clients even request a performance, as well too, like a set number of like, can you pack this number of boxes per hour, this number of boxes per minute, this kind of thing. So it has to be fast as well too. And so this is another video as well too about one of the applications that we built actually before DAE.com back in, I think, 2014. There's this major office supply store in Japan called Askell. It's kind of like the Staples.com of Japan. And we're able to do all of this e-commerce order picking automatically for them as well. And this is using a variety of different things in the totes. Yeah. And one thing about this business about doing these applications in logistics space is that these picking robots, they can be used in multiple different areas, which what we're seeing right now in industry is that there's incredible amount of demand for these kinds of systems in America right now. So already in Asia, Japan especially, it's pretty commonplace to see automation in these areas. I think that in the US, it's still a little bit, it has a little bit of space to catch up actually to Asia. But what these robots are doing are things like the depalletizing task, the palletizing task as well too. Also the picking task as well. All these things happen sometimes in even one warehouse. They'll do all these things. So that's the reason why we focus a lot on this kind of application. Now for different applications, like the bin picking, the palletizing, depalletizing, factory automation, you have to think about what kind of hardware really suits the application specifically. Like what kind of things you're trying to pick up, what kind of things you're trying to palletize. So there's a variety of different robot hardware that we have to work with. Also, as well too, we figured out a way that we can automatically generate the kinematics for the robot itself, solving a lot of problems there. This system that we have, it can be used for any kind of robot. And our system, our algorithm, it has a lot of advantages over other kinds of algorithms out there. Of course, the reason why we built this kind of thing is because there's real constraints on the performance that are made whenever we're trying to build these applications that are actually useful for clients. Also the gripping as well too. There's a variety of different kind of research that we've done around gripping, how to pick up the items reliably. And then also we have a variety of different kinds of grippers depending on the picking application, suction grippers, multi-finger grippers, these kinds of suction hands as well too. And then figuring out how to actually pick them up, which pads to use as well. And we built a system that can calculate and determine these kinds of things automatically based on the item that the robot sees in front of it. Now, just a little bit about the kind of software that we had to build to be able to make this, the kind of logic we built into it. This is an example of a video right here of something that it's very typical of what we do. Which is depalletizing this stack of boxes, but you notice there's different shapes of boxes involved, different sizes. And so this is a thing that Mujin's system really excels at doing. But to be able to make this kind of thing, you can't just use a motion planning algorithm and a robot. It actually has to look something more like this right here. This massive amount of code to be able to make a system that's really reliable and able to perform these functions. This is kind of the bare minimum. Yeah.
In the vision pipeline.
Yeah.
So is the vision pipeline only to identify if there are objects in a bin and just to detect them, to do object detection, or is it are vision algorithms used for other tasks?
The question is what kind of vision algorithms are we using?
Mm-hmm.
Yeah. So at Mujin, we actually have 3 major vision pipelines that we maintain. There's, we of course have a system that's going to identify obstacles in the scene, like identify where the barriers of the cage or the box, things like that, so the robot will hit them. Then we also have a pipeline that's for identifying the pose of the object and also identifying the object itself as well. So it goes beyond just identifying what's the object. We also identify the pose of how to pick it up. Because you can identify it in things like this, but if it's laying sideways where it's expected to be standing up, then there's some challenges in picking it up that way. Right? The robot could damage it if it didn't see where the objects are in the box or on the pallet or wherever it is. We have a kind of pipeline that we use the CAD models, actually of the items, especially for those, like the kits example, where it had those pieces that it was picking out of the bin. So we have the CAD models, and we have another model that doesn't use the CAD models, essentially.
And how is like are there does the robot make mistakes when it picks things up, or are there any cases that it cannot handle when it finds an object?
Are there, so if it's encountering a new item, for example, is that what you're talking about?
No, for instance, if you have when I was trying to pick out parts from the bin, if it identifies the pose and if it identifies the object, we did a bounding box for the object, then is the problem like it will always pick it up correct. Like, it's a 100%.
Well, so I mean, identifying the object is actually something that's, I think, it's for us, that's like not the main task.
Okay.
For us, the main task is figuring out how to guide the robot to the item so that we pick it up correctly. Yeah, and then place it correctly, right? And yeah, there are some items that, you know, sometimes it's like new items, or maybe like, for example, it's in a different shape, it gets mangled or something like that, at the bottom of the box, something like this. And the robot's not able to identify it. And so we have a system that handle that, and actually the settings that can handle that depending on the situation. Right?
Does it also handle? This is like a follow-up question.
Yeah.
So does it also handle like soft objects?
Yes, we can handle soft objects, deformable objects.
Okay.
Yeah. I think that for deformable objects, we're not quite there yet. We haven't completely solved that so much. And in fact, that's one of the things that, you know, one of the reasons why I'm here today is because we're really looking for people who can do research and figure out how to solve that problem inside of Mujin. Any other questions about the vision? I definitely want to go into more detail about what it actually is. Just so going back to the software stack, you know, we also have to include all these other things, the base layer as well too. And so we built this really massive system around software at Mujin. And we used a big team to be able to do it. We have a core team of about 40 people who are just doing the software side. And then we have another group of people who are helping out with mechanical and setting up the robots, integration, things like this as well too. And just to go a little bit more deeply into vision, specifically, this picture of the blue bin right here is having the bounding boxes of what we're recognizing, right? This is to understand what's the item. And there's some reasons why we have to understand what is the item. For example, like what is the item depends on how fast, like depending on the item, we might need to tell the robot to pick it up a different way or a different grasp point. We might need to tell the robot to handle it more slowly to reduce the amount of force that's applied to it. Many different things to consider whenever picking it up. But essentially, it's to be able to move the items between the boxes or put them in places safely. And so this is an example of our robot that's what it's actually doing here is it's encountering an item that it's never seen before. Well, you know, we actually know what's going to happen because we deleted it out of the record. But what it's actually doing here is that you notice at the beginning of the video, what it actually did was it went and picked up the, go back to this. It picked up the side of the box because it has this big black line through the middle of it. And the vision system is assuming that it's actually two boxes, or actually it's one, right? And we have a sensor in the hand here that is going to be able to determine the center of mass of the item based on how it's being moved. And so we know that that's not probably the best way to grade it. And then after that, we have these barcode sensors right here on the side. So we're able to register the item, we understand what it is. And then after that, capture all the physical properties of that as in terms of how we're handling it. And that way, the next time we use it, we can actually make it go faster in a safe way. So if you think about this kind of topic, this kind of like what's the system that you need to make this happen, right? The task is really just remove the item from the container, read a barcode, and place it side by side to the next thing in another container, right? That's the ideal kind of application we're building. And what's really necessary to make that happen accurately for motion planning? Well, we have to know about what's the position of the item, the start, right? We have to understand about what's the position of the placement, what are the other objects in the placement too. Other kinds of obstacle information as well too. All these have to be in coordinates that are useful to the robot. And this is an example of the video right here of one where things don't go quite as planned, but we built logic into the system to be able to recover and plan different next steps to be able to make it actually execute the job, which is to take all of these. This is like a kind of a sauce that's used for stir fries in Japan, this item here. But let me fast forward a little bit because it only gets exciting towards the middle. So I think this is like the second or the third one. What you'll see is the robot's actually going to, yeah, there we go. It falls over. It wasn't expecting that to happen. Right, and so then it detects again, the robot moves itself out of the way so we can do detection on both sides, just to double check everything. And then we build the logic in the system so it's able to keep on packing. And actually, if you fast forward a bit more, you can see it actually, there's a few other mistakes that happen as well too. But at the end of the day, it does what the customer wanted us to, which is to finish the job of getting all the boxes in it. So building that kind of system is the deep level of detail that we have, the thoroughness that we have to go into. Of course, automatic calibration is one of the things that makes that possible too. This example again, but going back to the sensors, there's also considerations about where we should put the sensors, how we should mount the vision cameras, and things like this. How much kind of detail is needed in 2D and 3D. Also, as well too, the speed of the robot as well. All these things are really practical for actually solving this problem of packing boxes. We also built, yes, go ahead.
Looks like there are a lot of sensor information involved while doing this stuff. So are you also solving the sensor fusion problem on? I see this is a very structured environment, but will there be a lot of errors from sensor data?
Yes.
How do you incorporate that?
So we do a lot of testing on the sensors before we actually deploy them. And that's one of the things that we have to build as well too. And actually, there was a pretty big project that we did for Uniqlo a few months ago, where I think they were going to have about like 10 sensors that they had to install in the warehouse. And at Mujin, you know, we're actually there's some manufacturers that we like using because the cost is not so high, and also because we know about the kind of software they're using. We built already some drivers and some interfaces with them. We like the kind of data they give us. So now they're our biggest partner that they have, essentially. We're buying the most sensors that they're making. And so they made like Mujin specific models for us, one of the things. But whenever we were setting up that warehouse, we actually had to go and find out what is the errors, what's the unique kind of properties of each of the lenses that's there. So we actually set up all the cameras one by one and then calibrated each of them, and then took them apart and then shipped them to the client's location and installed them, so that we would be able to understand about, you know, the unique like parts of each of these sensors. Yeah, reduce that kind of, you know, problem of having to do it on site and do it in the office instead.
Okay. So once you're done with testing, you completely trust the sensor and implement your motion planning algorithm, or is that corner case taken into account as well in your algorithm?
So,
like, what if something bad happens? Like, suddenly, if you get some very bad data from the sensor, can you ensure like the operation is quite safe?
yes, exactly. There's logic around that as well too. So there's some later videos I want to show you about specifically those kinds of things. But yeah, especially in Japan, like earthquakes happen all the time, right? And so whenever that happens, it might move the sensor like over like a few millimeters.
Yeah.
But that makes a difference in how the system actually will operate, right? And that makes a difference. And so we have to go back in and recalibrate based on that.
Okay.
So actually we have I talked about one algorithm, but actually what we're having is many different algorithms, many different settings that we can change in the system. it's actually still kind of a difficult system to use. This takes an expert, a trained expert, to be able to use it correctly. But having said that, though, compared to other conventional methods of doing it, it might take 6 months to make a similar application if you have a few engineers. At Mujin, we're able to get the same kind of application running in as little as a month, in some cases, like actually in production working. Yeah, and that's because we built out all of these features already, and it's just a matter of changing the settings and configuring for the hardware that we're using and things like this. Yeah. So back to the UI. This is actually one of the areas where we're innovating a lot. And the reason, and I gotta be clear, like the reason why we want to do this to make the UI better is so that we can make the setup time even faster. We want to have it so that eventually, even if you're not a robotics expert, you should be able to set up a robot. Because by doing that kind of thing, it's really going to become much more accessible and less expensive to be able to use. So we're doing a lot of research into UI right now. And then practical discussions. So here's an example of one of the things that the robot does. And again, going into like things that are unexpected, we have a person who's doing a little bit of being mean to the robot and moving the box, but after it's already done the detection. He moves it, and then the robot, it causes a collision. And our typical recovery from that is to actually just stop and wait for an operator to come and check out the scene, because we want to see if it's broken or not. And if the robot's broken, then it can't continue. So we have to actually stop in that situation. But in different situations, there's different ways of doing recovery. Did that answer your question you had earlier?
Yeah, sort of.
Okay. Well, just about our philosophy for how we actually make these robots. I mean, our philosophy, this is a hard job making these kinds of systems. But what we want to do is just, our philosophy is just never give up, continue solving the problem. And we really have to consider a lot of the real world constraints whenever we're deploying these systems. We're a kind of company that we have this idea, this theory of making it, but then actually doing it and trying out in the real world, we've learned so much from the industry itself. And we found that these systems, they need to work flawlessly. So our systems fail, for example, the errors that we actually have that are, you have to have an operator go look at them. We're able to get rates of like 1 in every 10,000, 1 in every 100,000 operations, which is actually what our clients expect. Because if the robot can't do the job without breaking down every few hours, why do we have a robot? You just have to have a person there to do the job instead, right? We're in the business of actually replacing the people from the client's standpoint. Yeah. So what's it like to work at Mujin? That's the last thing I wanted to cover with this. Feel free to ask any questions about this as well. The first thing I mentioned that, in Japan, around the world, actually, robotics is really booming. This forecast of 8.6% growth per year is actually a couple of years old. I think it was like 2020 they came up with this statistic. Just last year, the sales of AGVs and robots, the little mobile robots that work in the warehouses, they've spiked 25% in the US year on year. So there's definitely a lot of companies that are investing in this kind of robotics. Why is Japan a really exciting place to do this kind of thing? Is because Japan actually still has 3 of the top 5 robot arm makers in the world. Actually, about almost half the robots in the world are still made in Japan right now. And then of companies, the places where robots are being used, the US, China, and Japan represent 2/3 of the market globally. Just about our facility in Japan. We've actually got the largest robotics center in all of Tokyo. And it's about 14,000 square meters of space. I think in square feet, it's 166,000, I think it was, 168,000, something like that. It's about the same size as your baseball field over here. So it's a pretty big space. We have about 150 people in Japan. And it's got about 50 robot arms in different test configurations. We have people from all over the world who come to work with us in R&D. 26 different nationalities, I think maybe more right now. But they came from some pretty good schools. Actually, we got 4 people from Carnegie Mellon who were there. Some people from MIT, Berkeley, and Stanford as well too. We definitely like to have some people from UPenn. The types of people who we hire are people who are involved, really excited about robotics. And we have 5 main teams in R&D that are around building the robotic system, the motion planning algorithms, the computer vision area as well too. We have a team that does the front end, a team that does the back end, low-level communication APIs, and then also a team that does the simulation and testing. And that's actually the simulation side is actually pretty big right now as well too, looking for some good people there. We have openings that are full-time in Tokyo, internships in Tokyo, and then we also have computer vision team that we're looking to build in our Atlanta office that we established last summer. So our Atlanta office is 15 people right now. It's probably going to be double in a year's time from now, at least, maybe even more than that. It's growing really fast. And so right now we're looking for people who can help out with computer vision there. Now, to be able to work in computer vision, you don't have to be a computer vision expert. You need to be a person who can work with applied robotics, essentially, is what it is. So we have a really unique screening process, I think, compared to other companies, is that after having a chat with a Mujin recruiter like myself, or maybe one of my teammates, you'd have an initial tech talk with one of the team leads. And it goes pretty in-depth into your technical skills. And then the next step after that is to actually do a mini project with us. And the project is something that we've already solved before, but it's something that's directly related to what you'd be doing. There's a set of different meetings that you'd be doing during the project as well too. A kickoff meeting, a few meetings to touch base about how the project is going, and then after wrapping that up, then you might have a meeting with our CTO, and then that would be the end of the process. And for our internship program, the interview process is actually the same, although sometimes we don't do the CTO meeting. One neat thing about it is that we're inviting people to come to Tokyo, work for 3 months with us as a member of the team. You report directly to the team lead, and you actually do a kind of research topic. Something like one of these topics right here that I listed. If you have a specific research interest that's a little bit different, but aligned in some way, then we can definitely negotiate about that. And it can even be longer than 3 months if you need to. It's paid as well. And we want people to be able to contribute actually to our product in this internship. So the code that you make, ideally, is going to become part of our product, and then you'll be involved in the patent application process too. So just in conclusion, I just want to tell you, Mujin's making really the future of robotics, and our mission is really about automation, and we work as a really international team. So yeah, that's the end of my talk. Any questions for me? Sorry, it's so long.
You're mentioning too that they have an Atlanta office,
Yes.
so there's openings there as well, or not?
We were looking for full-time people in Atlanta. Exactly. Yes. It's a very small team in Atlanta. It's only 15 people, and so we don't really have the full-time lead there right now who can mentor an intern. And so we're looking for the internships to be in Tokyo.
And the internships are all on the topics that you listed.
There's a few others actually that are not in my list. And in fact, I need to go back and update with the managers about what kind of things we're looking for. But yeah, that's essentially, if you have something else that's related to these kinds of robotics that you want to study, then please let us know, because I think that we might be able to find some way that we can work together to be able to do your kind of research that you're interested in doing, and also at the same time make a contribution. I want to share also, I brought along some recruitment brochures.
And I can actually send them out aloud as well.
Thank you. Yeah.
So the internship,
Yeah.
is most of the work done at Mujin focused on like prototyping for products and like maybe patenting as opposed to publications?
Yes, it's right. So it's not, we can't be so open with the technology that we're making right now. Yeah. So if you're looking to publish papers, I think that we'll have to discuss a little bit about that, about what we're going to do in the future. But at the moment, probably not so open. Yeah. Yeah, absolutely. Any other questions about life in Japan or anything like this?
She's from Japan.
Yeah.
You're from Japan.
Nice.
Okay. Welcome. Yokoso.
Yeah, I like to watch the factory in Tokyo when I go back to Japan.
We often give tours. You're from
I'm from
University of
here.
Tokyo?
Yeah.
Yeah, so we have really close partnerships. Actually, Dr. Kanade from University of Tokyo, he's one of our board of directors.
Mhm.
Yeah, so we successfully hired quite a few people from the labs at JSK, Yamashita Lab, and also Asama Lab as well. And also a few other people who are working in other CS related areas. Yeah. So if you're interested to come for a tour, if you're interested to have a chat, then definitely we can do that. You can see the location. Yeah, and I have also done virtual tours in the past where I just use my selfie stick and go around the office and show you guys what we're doing. That's a lot of fun to do too.
Great. Thank you guys for attending in person.
Yeah, thank you for coming.
Thank you for attending online. I know people are dropping off.